Okay. So we're talking about data science, machine learning. You'll hear these words: artificial intelligence, machine learning, data science. What each of these things mean? Okay. So at the basic level, we have something called as machine learning. Okay. Now, what is machine learning? So just like we have human learning, right? You are
Mhm.
learning something. Okay. We are here to learn something. So just like we have human learning, we talk about machine learning, okay, where we are training machine. Now, why
Mhm.
do we train machine? Because machine can do a lot of work. It can work for 24 hours, 7 days a week, 365 days a year without any break, right? And we
Mhm.
human being, we can't work for 24 hours. We can hardly work for 8 hours. And then we fall sick and we cannot handle a lot of data like computers. When I say machine, it is computer, right? So they can
Mhm.
handle a lot of data, right? So obviously it makes sense for us to train machine to work things which for us is too much. So when we say that we are jobs will be lost because of machine learning, yes, some jobs will be lost which machine can do better, but obviously there are some other jobs which we can do better than machine. Those jobs, demand for those jobs will increase. Okay.
Mhm.
So yes, we are trying to make machine learn. The way we have school system, college system, university system is because you want to train the students, right? You want to
Yeah.
train them in a particular field of study so that they can start contributing to that field later. So same way we are making machine learn so that they can start contributing, right? So they can start performing later. Okay. So it is a subfield or subset of AI, artificial intelligence. Okay.
Mhm.
Now this is how I see AI. See, diamond and gold, they are expensive stuff, right? So if they
Mhm.
are expensive, obviously we have cheaper versions, artificial gold, artificial diamond, which look like
Yes.
diamond, look like gold, but they're not real gold, and price is very less, right? So those who cannot afford real gold or real diamond, they can go with this fake or artificial diamond and gold.
Mhm.
Similarly, we have human intelligence, which is the um, I think most expensive thing in the world, isn't it? With our intelligence, we can do wonders, right? We can send rockets to Mars. So
Mhm.
if we have such a strong, such a powerful and expensive thing with us, why not create a duplicate of it, or why not create artificial copy of it? If you can
Mhm.
have artificial copy of diamond and gold, why not have an artificial copy of our intelligence? So that's the whole objective of creating this AI field. Okay, so when you talk about AI, it is about creating that field where we are making machine think and act like us so that we can relax. Okay. So if you look at a human being or human intelligence, there are two main roles or the two types of work that gets associated with human being. One is what is called as thinking part, right? So as a human being, we do thinking or we do thinking and act. So we have think and act. They are two behavior of human being, isn't it? So let's say when you speak something, when you perform some action, when you do something, first you think using your brain, right? And
Yeah.
whatever you think is right, that you speak, that you perform, that you enact. Same thing we are, we are trying to use same concept, and we say that okay, machine learning is where which will help machine to think, right? A thinking of a 5 year old and 50 year old is different, right? 20 year old
Mhm.
is different. Now, when you talk about age, I mean that you expect 20 years to have learned more things than 5 year. Obviously,
Yeah.
if 5 year knows more things than 20 year old, then obviously 5 year old thinking will be better, right?
Yeah.
So the way we think depends upon the knowledge that we acquire, right?
Mhm.
So saying we said that okay, why not apply same concept to machine where we will make machine learn. And what is knowledge? Acquiring knowledge. Acquiring knowledge is data. What is happening here is I'm giving you some data and you're capturing the data in your mind, isn't it?
Mhm.
They said okay, we can also make machine learn. We can also make machine um, uh, become more experienced by providing data to the machine. So that's why
Mhm.
you need a lot of data, which will help machine be able to think. So the thinking part comes from machine learning. So when we talk about machine learning as a subject, we are we are talking about training the machine. One second. Okay. So yeah. So we're saying that the thinking aspect, the thinking part comes from machine learning. Okay. As we said, in machine learning, we are providing a lot of data to machine so that machine gains that experience. Okay.
Mhm.
And then the second part is enact part, the action part. Okay, so action part is part of your electronic, right, embedded systems where you take action. Okay, now if you ask robot to play football, so robot will first think, okay, with how much force I need to hit the ball, in which direction, in which angle, all those things. So that data is
I
given
lost
by.
you for some time. I couldn't hear what you said.
Okay, so I was saying that when you talk about if you want to train a robot to play football,
Yeah.
okay, so when you train robot to play football, so first part is that robot has to think, okay, with how much force I need to hit the ball, correct? In which angle should I hit the ball? Okay,
Mhm.
which direction I should hit the ball, right? Those are the decisions robot has to make, right? That is the thinking part. That comes from machine learning. Next part is just kicking the ball, right? That is your enact part. That comes from your electronic devices, embedded systems. Okay. So AI is has two components to it. One is your ML component, and other is this electronic components, IoT, what we call. Okay. So when you talk about robotics, they'll teach you about, you will learn about electronic devices, components, IoT devices, okay, how action, okay, the command, how the command, will make things move, okay. And then the thinking part comes from machine learning. So in our study, we'll focus on machine learning, not on the electronic component. We are not building a robot, but we are building the brains of a robot. You can think in that way, okay. We talk about how to make brains of a robot, okay.
Okay.
So now coming to machine learning, what is machine learning? Okay, so this is the definition I have written from some book. Okay, so what it says is, let me move this.
The page is, I think we're still at the AI.
Correct, correct. So if you read the bottom part, right?
A computer becomes okay.
Yes. So a computer program is said to learn from experience E. A computer program is said to learn from experience E with some class of tasks T and a performance measure P. And if its performance at task in T as measured by P improves with E, then we say that machine is learning. So I'll just explain you in simple terms. So if I give you a task today,
Mhm.
if I give you some task today, let's say on machine learning, and that is the task T, okay? And with some knowledge, okay, you have acquired some knowledge over the years, right? So that is your E. E is your experience. T is the task that I give you today.
Mhm.
Now, based on your E, when I give you the T, obviously you will use your experience E and you will answer those questions.
Yes.
Now, I will evaluate your question and give you a grade. Let's say that is performance evaluation. Okay.
Yeah.
I give you grade, let's say X. Okay. So that's what it says that today, if you perform a certain task with your given experience, your performance is P. Okay. Now, after the course ends, okay, when the course is ended, if I give you same task,
Mhm.
task remains same. Will your performance increase or decrease or remain same?
Oh, sorry, can you like repeat the question again?
Yeah. So I give you a task T related to machine
Yeah.
learning,
Yeah.
okay, and I measure your performance P.
Yeah.
Today I give you a task T, related to machine learning, and I measure your performance on the task T, I give you rating P. After the course ends, okay, once we are done with everything, then if again I ask you the same T, if I give you same task,
Mhm.
okay, will your performance P increase, decrease, or remain same?
It should get better.
It should get better.
Yeah.
Okay. If you are learning, then your P will get better.
Yeah.
That's what it says. With more experience. So what is that you're getting for next, let's say 2 weeks or 3 weeks that will be together? So your experience is increasing, isn't it?
Mhm.
For the next few days of session, your experience is increasing. So it's increase in E, your P also increases with respect to same T. T we are not changing. Task we are doing same. Okay, if
Yeah.
task also increases, then it's a different matter. But
Experience.
we
Experience.
yes, so we are keeping task T same. With increase with E, if your performance P also increases, we say that you are learning. So
Mhm.
same thing which happens with machine learning algorithm. You perform a test today with algorithm, okay, you get certain performance. Okay. Now, if you provide more data to it, if you provide more data, that is, you're giving more experience, then the
Mhm.
performance should improve. Okay. So
Yeah.
this is how we say machine learning. Now, if you talk about the programs that we've been doing so far, and then the program that we're going to do next is that the output is not going to be same. That's what it clearly says. Output is your task T that you have worked on,
Yeah.
right? So now if I do 3 plus 2, 3 plus 2 was 5,000 years back also. It's going to be 5,000 years later also,
Mhm.
right? But when you talk about um, mm, machine learning algorithms, okay, your performance will improve with more better and clear data.
Mhm.
Okay? So when we do machine learning and you see the output is not going to remain constant. It's going to keep on changing.
Yeah.
Right? Now, if I lock you in a room without any windows or door, and if I ask you whether it's going to rain tomorrow or not, you will give some answer.
Yeah.
And now, if I leave you in open place where you can actually see the weather, you can see temperature,
Mhm.
you have access to the weather data. Then, if I ask you whether it's going to rain tomorrow or not, the second answer is going to be better, isn't it?
Yeah.
More accurate because now you have access to more data, right?
Mhm.
So that means your experience has improved from your closed room to this open space.
Open space.
So obviously your performance has to improve. That's when you'll say that your brain is working.
Mhm.
If your performance doesn't increase, that means you are not learning. So this is what we say machine learning. It's the same thing with machine. If you provide more data, if the machine is able to perform better, and we'll talk about how to measure performance, okay? If your
Mhm.
machine is able to perform better, then clearly you are learning. Otherwise, you are not learning. This is
Okay.
what machine learning is. So machine learning is a subset of AI which talks about making machine learn to perform better. Okay.
Okay.
And this algorithm, so in machine learning, the algorithm, okay, the output or the accuracy or the performance of algorithm will improve based on data. Okay. And that's what we say machine learning. Now
Yeah.
let's talk about this example. Okay. So when I say apple, okay,
Mhm.
what do you mean by apple?
Fruit or apple company. I don't know.
Right? So
Yeah.
you would mean either red apple, it could be green apple or yellow apple, right? It could be
Yeah.
your company, right?
Mm.
Now, how do you recognize by these? So each of these are different, right? But you know them based on their characteristics, isn't it? So, example, the first fruit is red in color. It's a type of fruit. It has a peculiar shape. Okay, company apple is logo. It has its own shape. Color is sky blue, right?
Mhm.
So they have their own um, information, right?
Yeah.
Okay. Okay. So this is what we call as training. Okay, because so see in your when you were child, right, in your school, maybe LKG, they would have told you what apple is, A for apple, right?
Mm-hmm.
Now you know what apple is based on your experience.
Yeah.
Okay, because somebody has told you that this is apple, right? Now, so when somebody, now if I give you apple and say grapes, you can
Mm-hmm.
easily identify the difference between apple and grapes. How? Because grapes have a different properties and
Uh-huh.
apple has a different properties. So based on the properties, you can say that no, 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 this is not apple, this is grape, or this is not grape, this is apple. So
Mm-hmm.
same thing, okay, when you say learning, right? Okay, what is learning doing? Learning doing is same thing. It is making you, sorry, not making you, you look at the characteristics basically. You look at how, you know, um, logo apple is different than fruit apple. Okay, so what happens generally? Okay, we have so this is talking in terms of machine learning algorithm,
Mm-hmm.
but in our life, real life also, this is what we do. So if I, let's assume for a minute, okay, that you have never seen apple before, nobody told you what apple is.
Yeah.
Now if I show you apple and if I ask you what fruit it is, you will not be able to answer, correct? If I ask you
Mm-hmm.
name this fruit, you will not be able to answer as apple because you don't know, nobody ever told you, you have never seen such fruit,
Mm-hmm.
right? So you are without training, right? So nobody has told you, that means you have not done training in that. Now, if you had done training, if you had known, then you can easily answer that's apple, right? So in
Mm-hmm.
machine learning algorithm, also what we have is we have two components: the training component and prediction component. Machine learning is all about forecasting, prediction. Okay, that's what machine learning we are learning. Machine learning is all about. So what you've been doing so far on Tableau and Power BI is to measure what has happened,
Happen. Yeah. Past
right?
data.
Past data. Okay, who's your top customer? Who's your highest paid customer? Things like that.
Mm-hmm.
But if a question is who's going to be your highest paying customer next year,
Mm-hmm.
okay, so you have to use machine learning. So that's how machine learning is different compared to the other programming. Okay, so here your algorithm will not work, okay, or it will work, okay, since it's a mathematics model, it will work, it will give you some junk answer. Your
Mm-hmm.
machine learning algorithm will not work better, okay, or it will give you junk value. If you ask kids, right, let's say if you don't know anything, even if they ask what it is, they'll say something, right? So it's like when you don't know what apple is, and I show you apple, you say some other name, something you will say, but
Mm-hmm.
that is not correct, right? So first you have to train the model. Okay, to train the model, you see here in the first part of the box, you see you have label, then
Mm-hmm.
input, feature extractor, and features. Now input, feature extractor, and features are common in prediction also, but what is difference is label is not there in prediction, label is there in the training itself. Okay, so what are we doing here? Okay, so first, okay, okay, so
Yeah.
you have different algorithms that we need to use. Okay, and after a couple of slides, I'll talk about those different types of algorithms that are there in machine learning, which we use to make prediction. So this machine learning algorithms takes two input. Okay, one is input, one is output. So when I'm teaching you something, right, I will tell you the question also, right? And answer also. That's what it means. Teaching means what? I will ask you, it's like asking a question and telling you the answer. Now I'm telling you, how does machine learn? A machine learns using training model, right? So I'm giving you answer also. Label is like answer, okay? And input is like question. So
Okay. And
now
feature extractor.
I'll talk about it. I'm just going step by step. I'll talk about it. So treat this as input and output. Okay. So label is the output, the final output solution. So based on input and output, you are learning. Okay. And when I have to make prediction, obviously I don't know label, I don't know output. That's why I'm asking you to predict. So it takes the input value only. Okay. It takes the input value. Okay. Not the output value is what it will give you. So that's why you see model is giving us the output as label. So in training, it takes label as input value. It learns, okay, and now it says, okay, I have learned it. I'm ready to predict. I'm ready to predict. Then you give input saying, okay, this is the input. Give me the output. It says, okay, based on this input, this is the output. Okay, label is the output. Okay. So now, what is feature extractor and features? Okay. See, your when you say input and output, it has to be in form of table, rows and columns, right?
Mm-hmm.
So whatever data you have, even you have your video, audio files, okay, you have to create some kind of data, right? Some kind of data. So mostly we talk about structured data, and structured data will have your rows and columns. So rows, anyway, you have data, right? And
Mm-hmm.
what is important here is column. Column talks about what kind of data you have, right? So
Okay.
your label and input both are table input. Label is one column. So always, okay, in machine learning, your output is going to be one. So I want to predict whether it's going to rain tomorrow or not. Okay, I'm going to predict, okay, what will be the land price after 5 years. I'm
Or
going to
um highest sales.
highest sales. Yes, who's going to
Or
give me the highest sales, right?
okay.
So always it is about one column. Okay,
Mm-hmm.
we don't talk about two columns. We don't say y1, y2. We only talk about y equal to
Mm-hmm.
question mark. What is y value? Okay, so label is always about one column of the data set. Okay, fine. Now, to predict y, okay, you will not have just one column. You can have multiple columns. In fact, you will have hundreds of columns. Okay, tens of columns to predict y
Mm-hmm.
in reality. Okay, so your input, okay, of course will have rows and columns, and you will have multiple columns here.
In training or on I didn't get it.
Everywhere. See your data. See, I told you, right? Input and prediction, training and prediction, the input is same, isn't it?
Yeah, then it's the same.
Right. So I cannot ask
So
you.
when we say, I mean, in training, we're giving the the like output ahead of time. Uh, so I mean, what do we mean by that? Like,
Yeah, I'm coming step by step. I'm coming. Okay. So first I'll just explain, in theory, and then I'll take an example and I'll explain. So, so you have your X, right? Now, X, I just said, can have multiple values. So input, okay, are the factors that impact your Y.
mm-hmm.
Input is the factors that impact your Y. So see, I cannot predict Y. So I'm taking help of something which I know. Okay. So for example, simple example I'll take. Now let's say I want to predict marks that my student will get in the board exam, let's say. Okay. So let's say I'm a teacher and I have students who's going to write board exams.
Okay,
Now,
it's based on his I mean existing test score or
correct. So see, we're talking board exams, right? Now, board exams, your current students have not written,
yeah.
right? So based on current students, you cannot predict. But your last year students have written the board exam.
Yes.
You need to have some data, right? Without
Mm-hmm.
data, you cannot do the data or prediction. You need to have some data. So
Yeah.
my students, okay, current students, I don't know how much they're going to get in, let's say, 10th class exam. So what
Mm-hmm.
I'll do, I will go and talk to my previous student who have already done and passed. I'll say, tell me, okay, how much marks you got. Okay. Now the marks that they have got is your y, because we want to predict y only, right?
Mhm.
So marks that your student, because see now current student you don't know, but for
Yeah.
last year student you know their marks.
Yeah.
So you ask them, okay, how much marks did you get? Okay, they will say I've got, okay, 50, some will say 30, somebody will say 90, somebody will say 80. You note down name and the marks.
Mhm.
Then you ask them, okay, okay, various questions. Okay, you ask them various questions like how many hours they sleep, how what all things did they eat, okay, did they eat healthy food or not healthy food, how many hours did they sleep, how many hours did they study, how many hours did they watch TV, how many hours, I'm just giving you some example, right? So why is your marks? Because that's what you want to predict. Why is called
Mhm.
predictor, or the one that you're going to predict. That is why. Okay, and you're talking about factors that impact y. Those are your features, we call them. So you will have one single table where you have first column will be student name, then number of hours they study, number of hours they sleep, number of hours they play, number of hours they watch TV, what kind of food they eat, when did they get up, did they get up late, early morning, late morning. Okay, all those questions you will frame and you will ask them, because you think these are the factors that can influence why, right?
Mhm.
So you have collected this data from senior. So you have input and you have output. Now, before you actually pass on and you will start predicting, you need to figure out all these factors, okay, can impact my marks or not. Are they impacting the marks? This is called pre-processing step. You are doing this before you actually run the model. Before you want to run the model and start figuring out how much marks student will get, you're trying to understand, are all these factors, okay, impact the final output marks or not. So for that reason, we do different tests. You have a chi-square test, you have ANOVA, you have correlation. These are the tests we'll talk about, okay? These tests will tell you if there is a relationship between X and Y. How many X we have? Many
So
X.
these are all like algorithms, the ones
No,
you
no,
just
no.
mentioned.
No, we'll talk about algorithm later, okay? Just understand the theory behind it first, okay? Just understand the theory. Then we'll talk about what is algorithm, what is different thing, where algorithm come in. So what we are doing is, okay, we need to understand, right? We need to get training. We need to understand. No, as I said, right? Your task is to make prediction of the marks the student will
Is
get.
associated with his score or something. I mean,
Correct.
yeah, are they related?
Correct. But before that, you need to learn. See, you cannot predict marks,
Mm-hmm.
but but you can know the fact. If you know the factors that impact marks, then you can get marks.
Mm-hmm.
Okay, so this is what it means. Okay, let's say, for example, now let's say you want to plan and prepare for interview. You
Mm-hmm.
can't influence interview. You can't influence the interviewer. You can't influence the question that they're going to ask. So what do? You prepare well for the interview, right? Because you know that if you are prepared well, you can answer any question that they give you, right? So same thing. I don't know how I know. See, everybody wants to get 100, right? Nobody wants to get less than any. Given a choice, if you say, okay, you all, get your marks by yourself. There is no exam. You put whatever you want.
Mm-hmm.
Huh? Who will put less than 100? Nobody will put less than 100.
Yeah.
Everybody will put 100 marks to themselves. But of course, you can't do it. So what we can do is we can study for the exam. Okay. So when we test this, right? I told you that we perform the test. Test will
Mhm.
tell three things. If there is a relationship between X and Y or not. Each X will do. Okay. We spoke about 5, 6 types of X. Number of
Mhm.
hours you sleep, number of hours you eat, what kind of food you eat, when do you get up, you play or not. Okay. All these questions are, each of these questions are X. So you have X1, X2, X3, X4, X5. Each column become X, X1, X2, X3. Okay, and then you have Y, which is marks obtained. So before you run the algorithm, before you run the model, you need to, that's what feature extractor does. Feature extractors, each of these values, X are called features. Okay, the columns are called features. Okay, input columns. Okay, so as I said, number of hours you sleep, eat, play. Okay, all these things are your columns, and these are called features. So you have all these features, 10, 20, 30 features. But does all of them impact? Are they all relevant? So you perform the test, okay, chi-square test or correlation test or ANOVA test. Test will tell you whether this column impacts Y or not. Y is your marks. So number of times you eat in a day, does it impact marks or not? Okay. Number of hours you study.
So sometimes, I mean, we might have like false data, like something like I mean, it might actually like not impact, but if you're just taking,
We're not talking
say,
about one row, right? You have 1,000, 10,000, 50,000, 100,000 rows. Okay, out of 100,000 rows, if one or two or 5%, 2% is wrong also, okay, it's not going to
other,
have a large impact, right?
okay, yeah, yeah.
Point one. Point two is we also do something called as F test. Okay. Now F test is to check whether the rows are relevant or not. Okay, as you said, right? Wrong data. So now let's say I want to predict consumption of rice versus fancy dress, let's say. Let's say I'm Walmart. I want to predict how much how much clothing I will sell, high-end clothing I will be able to sell, or watch I'll sell. Now, prediction of watch is different than prediction of bread. I cannot use same algorithm. Logic will be same, but I can't use same algorithm, isn't it? I have to do something different, right? So your X can have uh, data about bread, and because Walmart, so you have all the data in one single table, right? So you cannot expect the bread data to help you to predict clothing sales, right? So we use F test, okay, and we assume that we have taken relevant data only, okay, and there are a lot of other process. We'll talk about it. Missing value, how to handle missing value, how to handle per feature scaling, column transfer. These are the logics, different things that you need to perform, and making sure that the data that you provide, as you said, right, is unbiased. Okay.
Okay.
Yes, you have to do all these things. As you said, rightly you said, yes, your data should not be biased, right? So there are some statistical tool, we'll talk about it, and there are some logical tool. Logical tool in the sense your brain, right? And we always give experience, okay, over statistics. Statistics may show that there is no relationship. For example, let's say, okay, statistics says that number of hours you play has no role with the marks that you obtained in the 10th board, let's say. But based on experience, you see that no, okay, for some reason you think that no, number of hours you play will have impact on the marks. So what principle of machine learning says is, if you think that way, go with that. Experience cannot replace statistics. Statistics are used only when you don't have anything to do. You don't know what to do, right? See, when you know what to do, you will not pray to God, or you will not look on internet, or you will not ask your friend. You will take the action. When you don't know what to do, right? That's when we start praying to God. We start asking people. We start doing googling. We start worrying. What will happen, right? But if you know how to handle it, then we don't worry.
Yeah.
Right? So same thing here. It says that experience will always will get preference over statistics. If you have experience, okay, then don't even worry to do any of the statistics work. But if you are new, fresher, you don't know what to do, then you have to justify every action that you are doing. Okay, so experienced people may not have to justify. If the experienced people say that this is it, nobody will question. Not the CEO will also not question. But when you are a fresher, new to the job, you cannot say that, no, I think this will happen, so this happened. You'll have to prove them using statistics. So statistics becomes much more, and see, that's what happens. Before machine learning was so widely used, people believed in experience. Okay, people will say do this and you will do that. Okay, but what happens? Okay, you will not have experienced people for always, right? So, you know, the experienced people might get transferred or may get retired. So you don't have that experienced person now. You have someone who is new, and then you cannot depend on what they say. So this is where statistics will be helpful. But as I said, always experience always will have a upper hand than um, the statistics. But
So
statistics
when
are
it comes
important when
to
you don't
data,
do.
yeah. So when it comes to like data, experience is previous data, right?
No, no. So let's say you want to predict sales, for example, right?
Uh-huh.
And you are in this predicting sales for 15 years, you are doing 10 years, you are doing that.
Mm-hmm.
So that's what I'm saying. So if you're already doing for 10 years, okay, then what you do is your process will be better than the statistical process.
Mm-hmm.
You know what factors will impact, right? You know what factors impact the sale price.
Mm-hmm.
Right. See, simple question. If I ask you, tell me whether it's going to rain today or not.
Mm-hmm.
So when I say whether it's going to rain today or not, you will not answer immediately. You'll start thinking, correct? What is the weather now? What is the temperature now? Which month it is? So generally, it doesn't rain here in the month of, say, March. Doesn't really rain, but then weather is cloudy. So what you are doing, you're thinking all these conditions in your brain, isn't it?
Right.
Based on whatever experience you have, whatever you know, you are using those knowledge, you're coming up. So those are features basically.
Mm-hmm.
So you're looking at the features. So if I tell you what is this, then you look at the features. So it's red in color, it's a particular shape. So this looks, then you'll say apple. Okay. You will not say immediately apple. You will look at the features of the fruit which I'm holding. And
Mm-hmm.
then mentally you will try to map to the fruits picture that you already have. And then you say, oh, this characteristics matches to apple. So this is apple. Oh, this characteristics matches to mango. So this is mango, right? So if I ask you whether it's going to rain tomorrow or not, or today or not, you are
Mm-hmm.
analyzing those factors, similar factors, basically. The
Right.
factors that impacts rain. Okay, let's say it doesn't rain in month of March. So obviously your answer will be no, it will not rain. So
This will
suddenly,
not.
no, there's a cloudy weather. Cloudy weather means it rains. So you'll say, okay, no, probability of rain is higher. Then you will not say it's not going to rain. You say, I think 60% chance of rain. So
Mm-hmm.
your output, your objective is not just blindly anything, right? You look at these features, and that's what we call them as features. Features are the factors that impacts the final outcome. Features are the factors that impact your final outcome. Final outcome is y. Okay, and your x1, x2, x3, these are your features that will impact the outcome. Is it clear now? Did you understand?
Yeah.
Now this will go to algorithm. Okay, so algorithm is end. Before algorithm, we have to perform all this. That's why we say pre-processing steps. Okay, the question that you asked, very valid questions. Are the data relevant? Okay, is the column relevant? All those questions you ask yourself, and you have some support by tools. You do it, and finally you clean the data, and the data is now inserted into your algorithm. Okay, we say right, junk in, junk out, right? If you do not perform all those questions, if you just enter the data, okay, you will get some answer. Okay, but you don't know if that answer is accurate or not. And when you test it, you will see the accuracy is very low.
Mm-hmm.
Okay, so feature extractor means out of all the features that you have, okay, which features you think are relevant for machine learning. Those features are extracted. That means those features are selected and added there. So when you see that features, right, not all features, the extracted features goes into your machine learning algorithm.
Okay.
Make sense so far?
Yeah.
Okay. So now your algorithm will will learn based on the label and why. So it says, okay, if this is input, this is output. Okay, if this is input, this is output. It is learning and creating some pattern. The pattern is created based on the machine learning algorithm that you give. Based on the algorithm that you give, the pattern is created. Okay, you change the algorithm, pattern will also change. And this is what we're going to learn later. Okay, so when it's machine learning, we are learning for what kind of data, which algorithm should we use.
Okay.
Okay, so some information will come from the features that you select. So based on the features, you will see that, okay, now this algorithm is better. And you cannot just select just one algorithm. You have to run 4 or 5 algorithms, and then you think which one is better. Right? So let's say what happens is, let's say you want you run a school and you have to send students to some competition. Okay, you want to send some student for a quiz competition, for example, let's say. Now you have thousands of students. Which student will you send for the competition? So you will tell them, okay, we have a quiz. So you'll conduct your own quiz competition, right? So you'll state to all the students that, okay, you have a quiz competition on so and so day. Those interested, please participate, right? So or you can even have a quiz classes in your school. Okay, we'll have a quiz classes. Everybody who's interested, come and learn. So you are doing the training. Training is about answer, question and answer both. Then you will conduct your own quiz. Okay, so now you figured out there are 5 students that has come in. Okay, so there are 5 students, and these 5 students have come into you, and they said that they want to participate in the quiz competition. But you can only send one. You can't send all the 5. So you will have your own
Quizzer.
Yes, and that quiz that you're talking about, okay, is for questions that you already know, right? If you are hosting a quiz competition, you'll ask the question for which you know the answer, isn't it? Then only you'll be able to judge who is the better. Let's say if you ask a question like which is the highest mountain peak in the world, but you yourself don't know the answer, then how will you judge them? You can't judge them, isn't it?
Yeah.
So we are talking about, okay, we are talking about quiz. We're talking about quiz for which answers you already know. So all the 5 algorithms or the 5 students that come to you, you will say, okay, you are trained now. I'm going to ask you a question. So you will, that's called testing. Okay. Prediction. So there's something called as testing in between training and prediction. Testing is purely for you to select 1 out of 5 models. See, I cannot put all the 5 algorithms in the final deployment. Okay. I have to select only one model. So what I'll do, I will train them. Then, okay, so training the data that you have from senior data that you have, let's say you took 100 data from senior. Okay. So when I took 100 data from senior, I will only give 80 data to the students to, for an algorithm to make prediction. So when you say label, right? So I'm not going to provide all the 100 past data. I will provide only 80 of the past data. I'll say, okay, these are 80 rows. Algorithm, you learn from these 80 rows. And you have hidden the 20. Why? Because you want to test it. Okay. How will you test? See, if I have to test you, whether you can predict weather correctly or not. For example, let's say. So if I ask you what will happen tomorrow, okay, so whether you to say rain or not rain, not no rain, I have to wait till tomorrow to see if your prediction is correct or not.
Yes.
Right? It's about future, right? So how can I judge you today? I cannot judge you today. So you will tell me an answer, and I have to wait till tomorrow to see how well you have given me the answer. So instead, what I'll do is I'll give you yesterday's data to you, or maybe day before yesterday's data, or maybe last year data, last month data I'll give you. This is the data. Now, based on that, you tell me whether it's going to rain next day or not. So you will see it will rain. Because since it is past data, right? I know the answer also.
Yeah.
Now I'll be able to evaluate whether you have said correctly or not.
Mhm.
So for same reason, even though I have the record of 100 students, I passed only 80 for training to the algorithm, and this rest 20, I will hide Y, and I will pass the X, and I will ask the algorithm to predict. So it's a prediction you're doing. Okay.
Yeah.
Prediction of the data for which you have the label, which you have the answer.
Already know.
So
Yeah.
the machine will give you the label. Then you compare that label given a machine to the output that you already have.
Mhm.
That's how you are seeing the performance. Now, if you see here,
Validating your model.
yes, evaluation, model evaluation. Okay. So since I have 5 students or 5 algorithms, so I will give all the 20 data to all the 5 algorithms.
Mhm.
Training same data set I'm training. And now I'm giving prediction. So now algorithm 1, let's say, has got 13 out of 20 correct. Model 2 has got 10 out of 20. Model 3 got 16 out of 20. Model 4 got 9 out of 20. Model 5 got 12 out of 20. So I know that 16 out of 20 model is better.
Mhm.
So I will select 16 out of 20 Walla model, which is, let's say, model number 3. And then I will say, okay, I'm going to deploy this in the final production.
Okay.
That gets deployed in the final production. Okay. So you're selecting 5, and then you are testing and you're figuring out which is the better model, and then you deploy that better model. So you have training, testing, and then final prediction. So testing is like predicting on the test data, training data, sorry. Okay. Testing is like predicting on the training data so that you have solution to evaluate the algorithm.
Okay.
And then you say, okay, this algorithm is best. You send it to the competition. You put it in the sending to competition is like sending it for prediction, production environment.
Okay.
And of course, you'll evaluate the performance. That process goes on. We'll talk about it. But at a core, this is the process. You train the data. Okay, you test it to know. You test it because you have multiple options. See, if you have only one option, then there's no need to test. Okay, you can directly use it for prediction. But when you have 3, 4 algorithms, you have a choice which one to select. So that's when you will perform prediction on the test data and see the performance on the test data and say, okay, algorithm A looks better.
Mhm.
Okay, so that's what your training and prediction is all about.
Okay.
Did you understand this?
Yeah.
Okay, so this is what we do. We'll take a data set, we will run it to algorithm, that is called training. So we'll train dot fit function is for training. So you train, then you pass the other X, say predict, give me the answer. Very simple. Okay,
Can you?
so types
Yeah.
of learning.
Okay.
How many types of how do you learn? Okay, so first type is called supervised learning. Supervised, any questions so far?
No, I don't have any questions.
Okay, great.
I just want to go back and go through everything again and then maybe come
Sure,
back
sure.
with it.
And you don't have to do it. I would say that don't go back now. Okay, maybe if you have time,
Yeah.
you just go through it. But when we do the example, right, you will be able to relate that.
Okay.
So
Like
types of
I'm just trying to understand like how
correct.
are
That is important.
AI, machine learning, Power BI, how are they all related? So
Right, right. So Power BI comes later, okay, or
okay.
comes before and later, okay, before to understand the data, okay, if X and Y are related or not. I told you,
Mhm.
right? Because we need to figure out correlation. Correlation you can visualize using scatter plot. So you will
Okay.
plot scatter plot before running the model to
Mhm.
see if X and Y are related.
Mhm.
Okay. So when you have both X and Y as numeric, okay, we talk about different types of testing, right? Correlation is shown using scatter plot, and correlation works when both your X and Y are numeric. So if you're
Okay.
trying to predict marks based on number of hours students study, so number of hours student studies is number of hours of numeric. Okay, marks is also numeric. So both are numeric in this case. You can perform scatter plot and you will find the correlation value and you know if there's an impact, no impact. Impact can be positive, negative. That means
Mhm.
more you study, more marks you will get. That means positive impact. More you watch TV, less marks you will
Get
get.
less.
That is
Oh, yeah.
negative correlation, isn't it?
Yeah.
So those are the things that we can visualize before we run. So that will tell us the relationship between data. You can visualize the relationship. You can understand the data better. Then you run the model. After the model is run, now you have the answers. So you want to present to your team to convince them to go with what you have done.
Mhm.
Okay. So as a data scientist, you will put on, you will do something. But ultimately, it's the business owner that is going to accept or reject your proposal.
Yeah.
Okay. So when you send a proposal, you have to make sure that you put everything possible so that your algorithm is, or your output is accepted by your management, right? So that's why we need to use Power BI or Tableau to do that.
Okay.
Coming to the types of learning, okay, the first type of learning is called supervised learning. Okay, how to understand is supervised means trainer. You have a trainer.
Mhm.
Okay, I always give this example. Okay, like when you were in lower KG or first class, second class, you will teacher will tell you that sun rises in the east and sun sets in the west. Correct, and you have so many poems and things like which talks about sun rises in the east. Now at that time, if somebody tells you that no, 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 sun does not rise, it is earth that goes around sun, you will start fighting. No, my teacher said this and this is true.
Yeah.
At that age, teacher says it is earth that goes around. No, sorry, sun that goes around, sun rises in the east, sun sets in the west. Great. Sun, teacher is right. Later, when you go to higher classes, higher school, then you realize that no, okay, it's
Mhm.
earth that goes around sun is stationary.
Yeah.
But when you go to even more higher classes, you realize that everything is moving. Sun is also moving, earth is also moving, this universe is also moving, galaxy is also moving.
Mhm.
Right? So what I'm trying to say is our learning depends upon the supervisor. Whatever teacher says, we remember. Now, even if I teach you wrong something, right? You trust me, so you will remember that. Because
Yeah.
you're listening to me because you trust me. I'm your supervisor. Now, I can, even if I say something wrong, so you will remember it as wrong only because as a supervisor, I'm telling it and you are listening. So this is called supervised learning. Learning. So we're talking about machine learning, right? How to make machine learn? So you have supervised learning. Supervised learning is the trainer. It's a trainer-based learning system. Trainer is there, and trainer will tell you, and you will believe. So how does this is achieved? This is achieved using the last example that we saw. That example is of supervised learning. Okay. So you have label, right? So label is
Yeah.
what output.
Mhm.
Somebody says this is a fruit and this fruit is called apple. Now,
Mhm.
at that point of time, if somebody showed you a figure of apple and said this is called banana, you will remember that as banana only.
Yeah.
So
Yeah.
that is an example of supervised learning where you have label data. Okay, label is the output. Why? Okay, so you have both question and answer. So that's why you it's called supervised learning. Unsupervised learning is like learning without teacher. In fact, if you look at most of the learning we do without teacher, okay, we see newspaper, we read newspaper, we see news, we look at TV, we see people around, and
Mhm.
nobody is telling you that, Sweta, you have to do this, you have to do this. Nobody tells you.
Mhm.
But when you look at it, your behavior changes, the way you act will change, right? So you are learning from the environment. Nobody is telling you, but you have learned it.
Mhm.
Okay, so here you will not have label data. There is no Y here. You have only input values. Okay, that is called as supervised learning.
Unsupervised.
Sorry,
Learning.
yeah, unsupervised learning. Okay, third type, which is really
So,
not
so
third type.
for okay, unsupervised learning, there is no output.
There is no label data. Yes,
Okay.
semi and weakly supervised is a function of both supervised and together. Okay, so I mean, though it is third, and there's some applications which are built on there, But this is really not a different type of learning, right? It's a mix of one and two only. I will see example and you'll understand. Third main type is called reinforcement learning. Okay, which is beyond our scope. We are not going to cover. We'll cover a little bit of it. Maybe we'll cover CNN, neural networks. Okay, but it is called feedback-based system. Okay, feedback-based system is where you learn based on the feedback. Okay, now generally when we are kid, right, when you do something and your mother scolds you, right, you'll show the eyes or you'll show the angry face. Why are you doing that? It's a way of giving feedback that what you have done is not right, not acceptable, right? So when you take certain action, like for example, we talk about driverless cars, right? Now driverless cars has to, or take car only, okay? The car has to stop at red light, right? Why? Because the rule says if you jump red light, you have to pay heavy penalty. So or the rule says that if you jump red light, you can cause accident. We do not want to cause accident. We do not want to pay fine. That's the feedback. Feedback is if you do this, then you'll have to pay fine. Obviously, you will not do that, isn't it? So we are looking at the end goal. We're looking at the objective. We're looking at the feedback. Okay, when you play a chess game, so you take so many. You think if I play this move, what will happen? You will lose, or you will. Who will have the upper hand, right? You will think, and then we make a move, because we know that if we do not play proper, opponent will win, right? If I do something like this, mother will scold me. Okay, if I do something like that, okay, I'll have to pay fine. So there's a feedback associated. We have award, right? Why do we companies give award? Because they want employees, they want to encourage employees to do that more. So if you give something, you say that, okay, if you do this, I'll give you chocolate. So chocolate is an award. That means if the output is what you desire, you give an award. That is called reinforcement learning. Reinforcement learning is learning by doing. So there is no data, there is no one to tell you what is happening. You perform a task, people appreciate you, they say, wow, good job. That means you will do it more. If they say, no, no, what have you done? That means you have to change your strategy, you have to do something different. Make sense? So reinforcement learning is learning based on feedback. Okay. So this is an example of supervised learning. Okay. The correct classes of the trained data are known. Okay. Now to explain this, let me give you an example. Now, let's say there's a one big empty room. Okay. And at the center of the room, I have put lot of fruits, apple, banana, grapes, and let's say mango. Okay. I have apple, banana, grapes, and mango in the center, and lot of not just one piece, but lot of fruits put there. And at the four corners, I have four bags. Okay, and each of the four bag I have given a label: banana, okay, apple, grapes, uh, and mango. So, can you not pick up these fruits and put it in the respective basket? Can you do that?
Yes.
You can do that. That is an example of supervised learning. Okay. Now I'll ask you a different way. Okay. Same example. Okay. A lot of fruit in the room. I had given four basket, four corners. The difference here is that, okay, you don't know the names of the fruits.
Okay.
So for example, it's the same example: apple, grapes, banana, and mango. Same example we'll take. And this example, let's assume that, okay, that you don't know the names of the fruit. Nobody told you what apple is. Okay. Now, can you segregate them and put them in four different basket?
No.
You can. Can you not segregate apple from
yeah,
banana even if you don't know the
yeah.
names?
Yeah, if it doesn't have a label there, then yes, we can.
Correct. It doesn't have a label. Correct.
Yeah,
I just said,
we
can you
can.
segregate? Yes, you can segregate. Right. But you don't have label. That's why I said label-less data. So you cannot say this is apple, this is banana. You cannot say. But
It's not categorized. Like, if you get this result, this is what this is. But
can
like
still put them together,
yeah,
isn't it?
yeah, yeah.
You can put them together, okay, based on the features, based on your X. That's what I call features, okay? Based on the features, based on the look and feel, right? Apple is different than banana. Banana is different than mango. Mango is different than apple. Obviously, grape is much different, okay? So based on the characteristics or features, you can still segregate them and put them in the basket. Only thing is that you cannot call it as label. That you cannot call it as apple or mango, right? That's an example of unsupervised learning. Unsupervised learning, you will be asked to categorize the output. You can categorize, but you can't name it. Okay, so you have to use your own name. You can say group A, B, C. You can say A, B, C, D. You can say X1, Y1, Y2, Y3, Y4, whatever. You can call it as, you can give it your own name to the final output. But you will be able to get the final output. That is what is called as unsupervised learning. Okay. The same thing which I spoke. You can still do it. Okay, you can still do it because you have, if it is red color and big size, it is apple. Red color and small size is cherry. Green color and big size is banana. Green color and small size is grapes, right? So based on the characteristics, you will be able to segregate them. That's unsupervised learning. And then reinforcement learning is the agent, the agent that is the work that is doing, and based on the feedback, if it is this, it is like, if it is award, you will do it more.
Yeah.
Right? Okay. Now, I will stop here because this will take a lot of time. Tomorrow I'll talk about it. This talks about the examples of the algorithm and some example, real life example of using that algorithm. Okay. So here what we have understood so far, we have understood first two rows, or in fact, first three rows you can say. Okay. So you have machine learning types. So we know what is machine learning. Types, we know at least in theory what is supervised, unsupervised, semi or weak supervised, and then reinforcement learning. Okay, so these are the four types of algorithms. Okay, now next row that you see is about the output variable y. What is y? So in supervised learning, continuous target variable, that is also called target variable. Continuous target variable means you're talking about y which is numeric. You're talking about y which is numeric. Okay, so if it is supervised algorithm and you are trying to predict numeric value, then you have to use a regression algorithm. It's a family. Okay, so in regression also you have tens of algorithms. Okay, and we will see which of those tens of algorithm, but at least category, that you'll have to use regression. So remember, if the output is about finding how many, how much, okay, how much, how many, so it is about using a regression algorithm. Nowhere else you will see output variable as continuous. This is the only place where continuous variable is there. That means you are asking to predict a number. Okay, how much will be my sales? How many customer will buy? Okay, these are your number, right? So if your output is about number, you will be using continuous target variable. You will use continuous target variable. All right.
So can
Next,
we
we'll talk about categorical type.
can
The
we do
output
this?
of categorical type. Y is of categorical. That means I'm asking to predict yes or no. Will customer buy? Yes or no. What type of,
Can
fruit
we
you
do this
want?
tomorrow?
Oh yeah, we'll do tomorrow. We'll do tomorrow. Okay.
And before you leave, like, can you